So today we'll talk about MedGemma, which is a very specialized medical intelligence model which can be run right on your computer. It is developed by Google. So now we have AI that can speak the language of medicine, not just the language of data. So these are the contents for today. First, we'll look into how AI is accelerating healthcare, followed by what is MedGemma 1. We'll also talk about MedGemma 1.5, followed by some of the performance benchmarks of these models. Then we'll talk about MedASR, and finally the global research impact of these models. So how is AI accelerating health? Healthcare is actually adopting AI at twice the rate of the broader economy. Google's HAIDEF program is actually part of this transformation. We are saying that open medical models have become the foundation for the global innovation in healthcare. We can observe that there are actually millions of downloads for these models, which show the scale of this demand. And this can be used like simply and also scaled through platforms like Google Cloud and Vertex AI. So AI is no longer just a tool for healthcare. It is becoming the new operating system for it. So what is MedGemma 1? It is an open medical specific generative AI model which has got two variants, the 4 billion and 27 billion parameter variants. It is built on the highly efficient Google Gemma 3 architecture, which actually uses a decoder only transformer for its logic, and it is also integrated with a medically tuned SIGLib vision encoder. It has been trained on various public datasets, which is which actually contains a lot of images and information on radiology, histopathology, and so on. It can support multimodal or 2D input with token size of 128,000, which is actually very huge, and it can generate up to 8,192 tokens of text on clinical reasoning or analysis. So now we have AI that can understand both general knowledge and also clinical precision. So what is MedGemma 1.5? It is an update of MedGemma 1, which has been released recently. It can support high-dimensional medical images, mostly 3D representations of CT and MRI imaging data. It can also enable complex diagnostic reasoning across entire 3D volumes of input. It can provide deep spatial context for surgical and diagnostic planning, and it can also help in extracting insights from the unstructured reports as well. So, we can now bridge the gap between advanced tech and the compassionate care in the medical centers. So these are some of the performance benchmarks of these models. We can see that MedGemma 1.5 model has performed better than MedGemma 1 in like all of these metrics, and these are the metrics for medical imaging tasks, and particularly for histopathology and this chest metric, it has performed significantly better than MedGemma 1. And for medical text tasks, the MedGemma 1.5 model has also performed better in both MedQA and EHR-QA metrics. So now let's talk about what is MedASR. MedASR is a new open model also developed by Google. It actually stands for Medical Automated Speech Recognition, and it has mastered the specialized vocabulary of the healthcare domain. It can be used to transcribe medical dictation between conversations between doctors, clinicians, and the patients, and it can serve as a natural voice-driven prompt generator for MedGemma, and it can reduce the clinical burnout by automating the transcription workflows, which is a big save. So now we can empower the hands that heal with the intelligence that knows. So what has been the global research impact of these models? We can see that Kaggle has recently hosted this competition, the MedGemma Impact Challenge, which has $100,000 in prizes, which is huge. It focuses on the real-world impact of these models. Then we can see that Malaysia's QMed Asia has used in the Ask CPG, which actually navigates over 150 clinical practice guidelines, and it provides practical real-time decision support for the doctors, which is great. And also we can see that Taiwan's National Health Insurance Administration has used it to evaluate pre-operative assessments for over 30,000 plus reports for the lung cancer surgery, which is a huge scale for data processing that was previously very difficult. So, if AI can now see, hear, and reason with clinical precision, what is our excuse for not using it to save more lives? So now let's test this model. So I just collected this code from Hugging Face for testing the MedGemma 1.54 billion parameter variant model. So I also modified it a bit to include a Gradio interface, as you can see over here. So I just gave it this particular URL of this X-ray from which it collected this image, and I asked it to provide a description for the image, which it did quite well. So as you can see over here that it actually gave me an overall idea followed by some specific observations of this X-ray and also an overall impression. So this is just the 4 billion parameter model. I think with the higher 27 billion parameter model, it can perform even better.